So let's discuss about framing techniques in data link layer. To provide services to the network layer, the data link layer must use the services provided to it by the physical layer. What the physical layer does is accepts a raw bit stream and attempts to deliver it to the destination. If the channel is noisy, as it is for most wireless and some wired links, the physical layer will add some redundancy to its signals to reduce the bit error rate to the tolerable level. However, the bit stream received by the data link layer is not guaranteed to be error-free. It is up to the data link layer to detect and, if necessary, correct errors. The usual approach is for the data link layer to break the bit stream up into discrete frames and compute the checksum for each frame. When a frame arrives at the destination, the checksum is recomputed. If the newly computed checksum is different from the one contained in the frame, the data link layer knows that an error has occurred and takes steps to deal with it. Breaking the bit stream up into frames is more difficult than it at first appears. So because of that, we follow some 4 methods to do this procedure, that is byte count, flag bytes with byte stuffing, starting and ending flags with bit stuffing, and physical layer coding violations. Now we see the first technique, that is byte count. This first method uses a field in the header to specify the number of bytes in the frame. When the data link layer at the destination sees the byte count, it knows how many bytes follow and hence where the end of the frame is. So the technique is shown in the following figures. So if you see this, the first number indicates the frame count, that is by how many frames it is followed by. And the same thing, if we see in the figure B, we can identify some errors as shown in this frame structure. The second framing method gets around the problem of resynchronization after an error by each frame start and end with special bytes. Often the same byte, called flag byte, is used as both the starting and ending delimiter. This byte stuffing is shown in the figure. 2 consecutive flag bytes indicate the end of one frame and start of the next. Thus, if the receiver ever loses synchronization, can just search for 2 flag bytes to find the end of the current frame and start of the next frame. Still, there is a problem, so we need to solve this problem. It may happen that a flag byte occurs in the data, especially when binary data such as photographs or songs are being transmitted. This situation would interfere with the framing. One way to solve this solution is to have the sender's data link layer insert a special character escape byte just before each accidental flag byte in the data. The data link layer on the receiving end removes the escape bytes before giving the data to the network layer. This technique called byte stuffing. The byte stuffing still is having some slight simplifications of the one used in point-to-point protocol, which is used to carry packets over communication links. The third method of delimiting the bit stream gets around a disadvantage of byte stuffing. So we are going for the next technique called bit stuffing. When the receiver sees 5 consecutive ones followed by a 0 bit, it automatically destuffs the 0 bit, just as byte stuffing is completely transparent to the network layer in both computers. So is bit stuffing. If the user data contain the flag pattern 0, 1, 1, 1, 1, 1, 1, 0, this flag is transmitted as 0, 1, 1, 1, 1, 1, 0, 1, 0, but stored in the receiver memory as 0, 1, 1, 1, 1, 1, 1, 0. The last method of framing is to use a shortcut from the physical layer. This redundancy means that some signals will not occur in regular data. Many data link protocols use a combination of these methods for safety.